Good day, everyone. How has been your day? Today we begin lecture on OOP programming language with C++, that is using C++. Then this topic is trying to target majority of the science and engineering students where OOP in computer science and computer engineering is all about. Today, we look at the overview of OOP concepts. We look at also the reason why we choose C++ over Java programming languages. Also look at the reason why we don't also choose C#, the .NET framework. But let's look at OOP, a concept in general. OOP is a programming paradigm centered around the concept of objects, which can represent the real-world entity. An object can be anything. Human being can be objects, a person is an object, a kind is an object. But what contributes to this is that every object has a state and behavior. This concept comes in to enable us to be able to modularize the problems, the real-world problems. OOP aims to provide a clear modular structures for programs, making them easier to manage and extend stability. OOP development is a powerful way to structure and manage software projects by focusing on objects. That's anything that I said it earlier, anything that has state and behaviors. Developers can create systems that are modular, reusable, easier to maintain, that is also more be backward compatible. The parties of OOP provide a robust framework for solving complex programming challenges, making it a fundamental paradigm in modern software development tools. We have an example of programming language that supports OOP, which are C++, we have Java, we have Python. I don't also have classes, anything that has classes. Language that has classes, that makes use of classes. C# as well. We look at the benefits of this OOP. Leveraging the principle of OOP, developers can create modular reusability, reusable component or reusable programs. Look at it. Let's look at the concept. Let's look at it. We have modularity. Code is organized into discrete objects or components, making it easier to manage and understand. In science, a method will break down problems into modular so that we can easily solve the problems. You cannot just solve problem the way we see the problem or the way the problem approaches. Sometimes can use theory. But by now you break them down into modules, able to solve the problem bit by bit with shop and element. Classes can be reused in different programs. I'm going to see them in this course. Also pluggability, you can plug and play, you can plug some things, some modules and get it into other modules. So also maintenance. Also look at, you see our OOP versus procedural programming. Although, let me pause a little bit here. Why are we firstly going through the theory and some basic principles here, some short pages we have here? I want you to have the basic graphs of what OOP is all about before we jump into the coding. In this aspect, I also go to look at the installation aspect of it, what you need to do to be able to start with it. It's not something difficult at all. You just need to put your mind together and make yourself ready with focus. It's not a big rocket problems. Just simple thing called this OOP, programming language. You can also use for OOP is ideal for large, complex, and scalable applications that require modularity, usability, and maintainability. compared to procedural programming languages, see that with simpler example of them, we have Ada, example of it. We have Ada, we have COBOL, we have BASIC, we have Fortran. There are a sample of Fortran or procedural programming languages. Also, here are some pictures of it, of OOP. You can see encapsulation is very high, it's low in procedural programming languages. You also have polymorphism. These are the things we're going to look at with code, seeing them in code. Why do we not choose C++? C++ offers low-level control, high performance, and is well suited for applications requiring efficiency and direct hardware interactions. As an engineering student, your focus and your goal is to be able to write a C program and be able to interact with the hardware machines. On the other hand, on Java excels in platform independence for writing enterprise applications. And these are some reasons why we chose Java, because here at early stage, developing the course for engineering students, also science also is part of it. Science student, it's not left out. So C++ offers more low-level controls over memory management as object behavior as compared to Java. In terms of performance, you also see that C++ is generally considered faster than Java due to its compilation. Like no Java virtual machine. Java makes use of JDK, but C++ doesn't make use of JDK. You can also see system programming. Want to program systems. If you anything that can chat with machines, hardware machine, complex machine, C++ is a powerful tool that is required. Also versatility as well, very versatile, pure OOP languages. So what are required tools that you need to know? To get along in this course, you need new essential tools like text editor, like our VS Code, gedit, text edit. On Linux, we have gedit. Also have VS. You can also have a Atom. You have to use Atom. You can also use code block. You come to editor, we use code block. We use Eclipse. We also use Visual Studio. We use C-Lion. And C-Lion is part of them. So what are the compilers that can be used? This compiler is C. There are many compilers. We have the commonly used one. They have the GNU compiler collections. GNU compiler collections, a widely used open source compiler. You can go to Softnet. You can download it from there. Of course, you have CLang, you have ngWin. Also, our Microsoft compiler, we have Turbo. So these are the things you can use. But let's go to the process how you can really set it up on your Windows platform, or maybe a Linux machine, or Mac OS. You can also see, let's go to the basic requirements of it. Go to SoftNet, sourceforge.net, pardon me. Also, you download the latest versions, or if you're on Windows, you download it. If you're on Linux, you can also download that. But Linux you can easily run, depending on your distribution. If you're on Ubuntu Linux, you can easily make use of. Just open your terminal and type apt install. Just open it and just type it and just show you. Just show you terminal. From there, for my terminal, can just go on coming for my terminal window. Okay, now good. All right, and it's a D. If you are in Linux, I'm using Fedora. So I just said apt install, but you have to be admin. You have to use sudo apt install GCC. That's that. So apt install GCC should should install that and other development tools you're going to be using. By just following this documentation, you should be able to just apt install built-in essential, install the packages needed. Also, we have also for GCC13, if you want to be specific about the version of the one you want to install, you can also put 13 at the back of it to show that you're installing 13 version of it. For example, if you are using Fedora just like I am, you can just easily say, okay, let's go back to the terminal. So just type, okay, now we just type, I think now just say, okay, sudo apt is, and this is not supported here, sudo dfn install start. So dfn install this. That is GCC. It will automatically install it for me. Yes, GCC, which is this. As for my password, I supplied. You can see it already told me what I have a version here installed already on my machine. So I don't need to install it again in case you've not installed it on your machine. Let's go back to our slide just to cap it up. So you can see on your Mac OS, the same thing here. Follow this distribution something, and you install it here from your Xcode. Install this version, and on Windows machine, then we download it. After downloading it, so we check before installation. You check it here. We have GCC version. It's not recognized here. So we move on to the next steps. When after downloading it, you just copy the file, the GCC, come to your C folder, come to your C, your root C, copy it anywhere you copy it on your machine. Doesn't matter. But just make sure what matters there is that just set the environment so that your environment variable your system environment can recognize it. So that's it. That is the main important thing about it. You follow the slide here. After you've done it, so you point which is more very important. This library. Open the folder, the GCC folder, open the bin, then copy this part and go to your system environment. Right click on and go to manage, or from your start menu, just type system environment variables, or you right click on your system icon and go to what manage or settings. You see advanced system variables. You come there, you enter it in. Also, you set the path. Come down, you set the path. You come here to down here. Can you see? Come to the part here, edit this part. After you editing it, just come down, you just paste it here. After you click on new, just click on the line and you paste it here. Then you okay. You ensure you okay everything. Don't close any other one. Ensure you close all the dialog is closed. Then go back to your terminal. Close the previous terminal. Then reopen the new terminal back again. Type it on your command prompt now. You should be able to see the version installed. So that is the end of the slide. So therefore, after completing all those steps, what we're going to do now is to open our VS Code. And after open our VS Code, we give the settings. Just come to this place. You click there. You open a folder. Just say yes, I trust this folder. Open a folder. You can create a folder. Maybe open a folder to anywhere. Select your document here, or create a new folder by clicking on create a new folder. You create a new folder and you save it and you open it. Then you open it here. I name this one as CPPOP. Then you create a file here, new file. Before then, let's go to the market. See this icon, your VS Code. I'm using VS Code for example. So just come here, your VS Code, and type in C/C++. You can see here, we have 65 million installed. So you download it. It's an extension that enables you to have IntelliSense on your machine. So Then we go here, like just .ccc or .cpp or this. The two extensions supported. So CPP, this, then we have our file here. Then we have include, then we start here next lecture. I think if any question, please drop the comment sections. Thank you. Bye-bye.